Okay, welcome back to Klein's Geometry. We're going to look at 8-1, finding triangle lengths. We've already talked about geometric means and similar triangles. So here you see a triangle, three triangles, with a small, medium, and large right triangle, all similar. I've written the similarity statement, right angles, C, C, and A, up the short legs, B, A, and B, and then my third angle. Now when you look at the ratio between these triangles, some interesting things happen. Notice if you look at the small and the medium triangle, CB over CA is equal to CA over CD. And that's going to give you CA squared equal to CB times CD. Now, why is that interesting? Well, this number squared, this length, equals this times this. If I know these two, I can find this altitude quite easily. Just the altitude squared equals this side times this side. Now, if I look at the ratios between the small and the large triangles, I see that CB over AB here equals BA over BD. That's going to simplify when I multiply, BA and AB have the same length, to AB squared equals CB times BD. Well, that makes this length squared equal to the piece directly across from it times the whole thing. Again, if I know these two pieces, I can find this one now. If I look at this ratio between the medium and the large triangle, you're going to see the same relationship happening. CD, this over AD, will equal AD over BD. Well, again, if I multiply this, AD times AD squared, it's equal to CD times BD. Which means this side, AD, when I square it, equals the side across from it, CD, times the entire length here. So, neat relationships. Let's use these three ideas to find triangle lengths. Looking at this example, we have a right triangle right here, and we have an altitude, so we know we have three right triangles. We want to find X, Y, and Z. Okay? So we always start with the middle value, coming up the middle. So I'm going to say X squared equals, now this times this, always. So I'll say 2 times 10. So X squared equals 20. Now, when I square root that, 20 is not a perfect square, so I'm going to break that into factors where 1 is, and call it the square root of 4 times the square root of 5, because the square root of 4 is 2. So I get for X 2 times the square root of 5. Now when I look at Y, right along here, I know Y squared equals the piece directly across from it, 10, times the entire length, which is 10 plus 2, so 12. That makes Y squared equal to 120. And when I square root both sides, Y equals, I need a perfect square here. 120 is not it, But I see 12, and I know 4 will go into 12. So I'm going to call this the square root of 4 times, and 4 goes into 12 3 times, and there's a 0 left over. So the square root of 4 times square root of 30. That makes y equal to 2 times the square root of 30. Now I know the square root of 30 only has factors of 2 and 15, either perfect squares, or 5 and 6. So this is as good as it gets for y. Finally, for z is along this side, so I know it's going to be this length across from z, 2, times the whole thing, 12. So that makes z squared equal to 24. And again, I'm going to use that 4 as when I square root. 4 is just a beautiful thing. It's a perfect square, so I can call it the square root of 4 times the square root of 6. And the square root of 4 is 2, so I end up with 2 square root of 6 in simplest radical form for z. Okay? So again, x squared, this side times this side. Y squared, the piece across from it, times the whole length. Z squared, the piece across from it, times the whole length. So that's always what you're doing when you're doing this. Let's try one more. Okay? We want to find u, v, and w. Okay? So I know I have to deal with my middle first. So I know 9 squared equals 3 times w. Then I'll take 9 squared and get 81 equals 3w. Divide by 3 and get w equal to, 3 goes into 8 twice, that's 6, so there's 2 left over. And 3 goes into 21 7 times. So w equals 27. And I'm going to have to put that here because we're going to need that as we find the rest. Now if I want to find v, this length here, v squared equals, well, it's going to equal the little piece across from it, 3, times the entire length, 3 plus 27, so that's 30. That gives me v squared equal to 3 times 30 is 90. And when I square root that, well, there's no perfect square for 90, but there is for 9. So I'm going to say v equals the square root of 9 times the square root of 10, because 9 times 10 is 90. And that's going to give me 3 times square root of 10. So there's my v. Now, for w, excuse me, I already have w. Let's find u instead. For u squared, I know that equals the piece across from it, 27, times the whole thing, which is 30. So multiplying, 3 times 7 is 21. Put down the 1, carry the 2. 3 times 2 is 6. 2 more is 8. And since that was a 30, I'll add my 0 at the end. Now when I square root this, I see that I have a perfect square here in 81. So u is going to be the square root, and I'm going to say 81 times 10, because 81 times 10 is 810. And then that perfect square, 81, can be square rooted. Square root of 81 is 9. So I end up with 9 times the square root of 10. Always. Up the middle squared equals this times this, the two pieces. This side squared equals the piece across from it times the whole thing. This side squared equals the piece across from it times the whole thing. So you can do that for each of these problems. If you know 2 lengths, you can find them all. So enjoy these problems, and we will see you in class.